we are setting the ID here. So self dot dash dash, we have ID here, which is a private attribute, is equal to ID. And self dot dash dash, we have the max speed, which is set to ms. Then we have self dot dash dash increase amount, which is set to IA. And then they're saying you are supposed to initialize current speed and horizontal position to 0 directly. Self dot current speed is equal to 0, and then self dot dash dash horizontal position is equal to 0, and this should also be a private attribute. Simple enough. Okay, then they are saying that we are going to all the attributes must be private. Okay, we have to do the attribute declaration as well. So this is of string, this is integer, this is also integer, integer, and integer. All right. Then in the next part, they are saying that we have to write code for the getter methods. Okay, very simple. So we have tried 1, 2, 3, 4 getter methods. We have to write define get. I'll just write all of these. Okay, done. Then they're saying write setter methods for current speed and horizontal position. So define set current speed, which will take a new speed and it will set it to the current speed. And then we have the define setter horizontal position, which will take a new position and assign it to the current value of our horizontal position attribute. Simple. All right. Then they're saying write the method increase speed. Okay. Write the method increase speed, which will add increase amount to the current speed. Okay, so it will add increase amount to the current speed, and then adds the updated current speed to the horizontal position. Okay, and then the current speed of the vehicle cannot exceed its maximum speed. So in this method, we have to first of all check if the new speed that we're going to get, would it be exceeding the limit or not. So we have the current speed here. This is the current speed that the car has right now. And then we have the increase amount. And then we have the max speed. So it shouldn't be exceeding that. Okay, so simple math. Let's say if the current is equal to, let's say 20. And then the increase that you do is maybe 50. So total becomes equal to 70. And let's say the max is set at 50. So this will not work. So we have to not allow this. So now we have to first check the current speed. So self dot current speed. If so, we're going to increase it by the current speed added by the increase amount, which is already given to us. Increase amount. So it's all part of the object. Current speed, increase amount, etc. Okay, now we have to check if it exceeds the maximum one. So if self dot current speed will exceed the self dot max speed. If that becomes the case, then they're saying that you have to limit it to its maximum speed. So what you're going to do is you're going to set the current speed to the max speed. Again, what's happening? So if the current is equal to 20, increase is equal to 50, and max is equal to 70, or maybe max is equal to 60. Now 650, since 50 plus 20 becomes 70, and your vehicle cannot exceed that, so basically you're limiting it to 60. You're going to set the current to 60 and it cannot go beyond that. So this is done, and then they're saying add the current speed updated amount to the horizontal position. So once this is done, at the end of the if condition, we'll do self dot horizontal position plus equal to self dot current speed. So whatever the current speed is, we're going to add it into the horizontal position, so it will be updated as per the given speed. Now in the next part, we are supposed to implement a child class that is called helicopter. So let's hide this class helicopter, and then this will have the vehicle as the parent class. So it inherits vehicle class. Okay, then they are saying that you are going to write the code for the helicopter. You only need to declare the class and the constructor. Okay, constructor says ID, maximum speed, increase amount, vertical change, maximum height as parameters. Okay, so we have the define constructor. So we have the ID same as the parent, maximum speed same as the parent, increase amount same as the parent. Now the only two new things are vertical change and the maximum height. And they're saying you do not need to declare. So what we're going to do is we are first going to call, since all of these three parameters are the same as the parent, we will call the parent parameter, and for that we'll use the keyword super. What does super do? It will take these parameters, and we're saying super.init. That means call the constructor from the parent class, pass these parameters there, and then get the object ready from the parent class without repeating the code here. Okay, since these are the overlapping ones, now we have two new ones. We have the vertical change at maximum height, and so we'll set self dot dash dash vertical change. We'll set it to the parametric value, and then we're saying that vertical position will be set to 0. Okay, this should be set to 0. This is vertical change, and the vertical position should be set to 0. And we have self dot vertical change, which will set to vertical change is being set to vertical change parameter. Then they're saying all of them must be private, so we've made them private. Okay, then in the next part we have to declare their types as well.
Declare.
Cell dot max height is equal to mx mh, and these are all integer values, I believe. Integer. Okay, this is ready. Then they're saying you have to go into part 2, the helicopter method increase speed. So define increase speed self, which will override the method from the parent class. Okay, so that means we'll be rewriting this in the child class, and then when we'll create the helicopter object, so it will be triggered from the child class. Adds the amount of the vertical change to the vertical position, add the increase amount to the current speed, adds the updated, okay, the vertical position of a helicopter cannot exceed its maximum height, and then the current speed of a helicopter cannot exceed its maximum speed. Okay, it's pretty much the same thing with a couple of changes. So self dot vertical position is equal to self dot vertical change. So whatever the vertical change is, we're going to add it, and we're going to update our vertical position accordingly. Just like in the case of vehicle, we were updating the speed based on the horizontal position, right? We were adding the speed into it. So this is done. Again, hiding it. All right. Now we are going to make sure it is within the bounds. So if self dot vertical position becomes greater than the maximum height. So if the car or the vehicle, whatever it is moving, let's say it's a helicopter, so it's flying, so it goes beyond the maximum height, then you're going to limit the position to the maximum height. That's it. And then they're saying adds the updated current speed to the horizontal position, adds the amount of vertical change to the current position. So once we are done with this, we'll do self dot, okay, that's already done. Okay, now we also have to set its speed. They're saying the current speed of helicopter cannot exceed the position. Now let's look at the vehicle class. Here we created a setter method. We are setting it the max speed at this point, right? So we have to use this setter method here. And for that, I'll simply make a call to the super class. I'll say super, and then I'll say set current speed, and then the current speed will be basically set to whatever speed that we have so far. Add the increase amount to the current speed. Okay, so add the increase amount to the current speed. Now for that we need to get the current speed. Let's get the current speed here. Current speed is equal to self dot dash dash. This would be also from superclass or get current speed. This gets us the current speed. And what I'll do is I'm going to set the current speed to the current speed that I have, and I'm going to add into this the increase amount. So they're saying adds the increase amount to the current speed. Let's also get the increase amount. Increase amount is equal to super. We'll call the parent class dot get current get increase. So we are calling both of these from the parent class. Here we have the increase amount. Here we have the current speed. We have the max speed, and we have the increase speed. So I'm calling those from the parent class. Let's call it increase. We're going to so we are going to add the current speed into the increased amount by whatever we're increasing the speed by, and then we are going to set it at the current speed of our vehicle, and then we have to do the same thing for the horizontal, I believe. That we have to add the updated current speed to the horizontal position. So we have the updated current speed here. Now we're going to add it into the horizontal position only if it does not exceed. So first we have to check if, again we have to call the super. So we already did that. We got the current speed. Let's get the current speed again because it has been updated. So I'm going to recall it like this. Now I'm going to check again if the current speed at any point goes beyond the maximum speed. Okay, now how do I get the maximum speed? We again have to get max speed. If it goes beyond that, then I'm going to again limit it. So I'll say super, and then I'll again set the current speed to the whatever max speed we have right now of our vehicle. So I'll just set it to the super dot get max speed. What I'm doing, if I current speed is let's say 100, and if the max speed is let's say 80, so I'm checking this 100 gives an 80, yes. So I'm saying that get the current max speed, whatever it's allowed, which is 80, and I'm setting it to the current speed. So this will basically make the current speed of the vehicle set to 80. And this is the complete part. All right, now to write the print position, they are saying that the procedure will output the horizontal and the speed of vehicle if the vehicle is helicopter, and also the output position if it is a helicopter. So that means it has to exist in both the classes, the vehicle class and the helicopter class. So in the copter class, it will print the horizontal position, the current speed, and also print the vertical, the current y, which we'll get from self dot vertical position like this. But since vertical position cannot exist in the parent class, so what we can do instead here is, because this will be rewritten in the parent class, there are two ways. In fact, you can just copy this, go all the way up, and you can paste it here like this, as they mentioned. Or what you can do here is, if you want to save these two lines of code, because we're doing object-oriented programming, since it's already written in the parent class, we'll just do super dot print position. So it will go into the parent class, it will print these two lines, and then it will go back, and then it will print the current value of y based on the vertical position that we have, and then we can run the code. And it says that the current x is 60, current speed is set to 40, and then the current speed is set to 80, and current y is set to 6, and this the question is done.